Hey guys, welcome back to Pop 'em Up Chem. Well, kind of. So today, all I'm really doing is going through the chemistry EE and some of the nuances regarding the chemistry EE and the expectations around it if you choose to explore one. So the purpose of this video is we want to understand the structure of the EE in chemistry, how it differs from the IAs, and begin to explore, hopefully, if you choose to, your own EE. So firstly, we have topic selection. So here we want to relate it to the course. Indeed, it must be related to the course, but we shouldn't take direct inspiration for the context of the course. The things we learn in the course can be applied in many different ways. So when we think about something like calorimetry, where we might measure the temperature change of a reaction and then use Q equals MC delta T, that's good stuff. But it's not very interesting by itself. But what we might do is we might think, how do we use the context to explore the world around us? So we might think of, to what extent is octane rating a measure of energy density of fuel pump fuels? Those are the things you get to put in your car. So the octane rating is a thing that stops knocking, or a rating that tells us how much knocking happens. So when we have a piston, obviously force is delivered to that piston by the expansion of a gas at high pressure. And with those expansions of gas, the high pressure inside can cause the auto combustion of fuel. As that cycle goes in, it gets sprayed in, explodes, expands. That's great, delivers force to the crankshaft. But because of that high pressure, as more fuel gets sprayed in, we can sometimes have a situation where we get an undesired explosion, and that's what causes something called knocking in engines. And so the octane rating of a fuel, that's a thing on the fuel pump that's rated up to 100, that rates how little that fuel does knocking, if you like, or how little knocking happens. So now we can see, okay, we might want to look at, can we use calorimetry potentially in an experiment to explore those things? So if we continue this, we want to research and explore interesting areas of your life or phenomenon that might not be suitable for an IA. So when we think about the title, we want the title to be a statement and the question to, I suppose we want it to obviously be a question, And that question, we want to be highly specific, and we want it to be debatable in some sense. So this might be simply the way that you can explore something in E is insufficient to answer a question in a complete manner, or you might find conflicting answers which may have different reasons. For example, let's take octane. Octane ratings, may be achieved through many different additives. Here, the additives they would use to reduce knocking when the fuel is exposed to much higher temperatures may be different from what they get in Finland, for example, where the fuel has to be a lot less viscous because it's exposed to high temperatures in the fuel tank a lot less. So they may use different additives. Now, what does that mean for you doing an EE in this? Well, it may be that those additives vary in the amount of energy they provide to the actual fuel, and therefore it may cause a variable that you can't really control, and most petroleum companies will not publish the exact composition of their fuels. So this is something that you would maybe have to explore through secondary research, and your experiment couldn't answer completely. And that's great, because now we're exploring something that is debatable, right? We were talking about the octane rating of a fuel. Well, you're going to quickly realize that you're not going to be able to reach an exact conclusion. It may be that you find good relationships between these things, but there'll be variables which you can't necessarily account for, which leave a good area for discussion. So when we talk about writing this thing, don't ignore the criteria, right? So we've got criteria A, B, C, D, and E. Okay, so you'll see that criteria C, which is critical thinking, has the highest weighting, which is out of 12. And presentation, for example, has only 4. So many students spend so long going, I need to get this MLA 6, 8, I don't even know what number MLA's on. It doesn't matter what citation system you really use, as long as it's consistent throughout the report. So you might just want to start collating resources and citations. For example, when you're submitting drafts to your supervisor, which may be me or one of the other chemistry teachers, we're not going to pay a whole lot of attention to the actual way you're doing your citations until that final EE. Whereas if you're critical thinking, where you're thinking about what are the variables that you may not have been able to consider, how does your experiment fall short, how is it really good, how did you try and mitigate error and uncertainty, all of those kind of things lead to critical thinking, which lead to more marks. I'm not going to go through all of the different criteria because that's actually the same across all EEs, and we'll probably explore that more with all of you, no matter which extended essay you do decide to take on. But just bear that in mind, that's where you should be focusing on. So in your research, have fun, right? I know that sounds stupid, but if you're procrastinating, look for weird stuff, look at YouTube videos, and kind of formulate from there. Like, are you interested in something that's well outside the framework of things that you study and enjoy in your chemistry class that have a chemical basis, and then build from there? Okay, I'm really interested in foundations, for makeup foundations and their composition. Maybe I'm really interested in the biochemical nature of some plants, or the concentrations of different ions that may be contained within them in different biochemical systems. All of these things may be really rich things that you might be interested in already, because you may be thinking about what you want to study in college, and may give you really fertile ground for an EE. And also remember that if you're applying to colleges, the EE is going to be something you're going to spend so much time on that it may be a good discussion topic if you get an interview. But one thing to keep in mind is, when we're researching, to keep a separate document of resources, initial thoughts, all of these kind of things. And the reason I would say that is because what most people try and do is they just try and start writing an EE. And the problem with that is a lot of your research might not make it, your question may change, it might not be as relevant. So I would keep a separate document as you start to research, start writing down your ideas, almost like a kind of journal. It doesn't take much effort. As you're watching a video, copy the URL into a Word document or a Google Doc, and then maybe lots of science information on YouTube will have sources in the description. So go into the description, look at those sources, copy those in, and you've already started building a bank of research. It can literally be that simple. For example, I watched a video when I was procrastinating this morning, instead of doing this first, which was about how recently Egyptologists, or people that study the history of Egypt, have been able to identify or start to identify the location of an ancient civilization to the south of Egypt by using strontium isotope labeling with the difference between the teeth of the bonobo and the bones of the bonobo, depending on where they were born, when they grew up. Really cool stuff. And this is happening throughout so many different areas of research. When we come to the structure of the essay, you want to think your intro should be short, precise, and relevant. And also, you may include it. Some people do include it in the introduction, some people don't, which is kind of your method or your approach. So in the sciences, we often think about method as step one, weigh out calcium carbonate. That is the methodology of the practical component. What I'm talking about here is the actual criteria you're giving yourself to answer this research question. So that may come in like mainly in two parts. The first part is maybe your kind of secondary evidence. So that's the research, what is relevant to the research question, and how you will evaluate the different perspectives. So I'm not talking just about here's the research I'll use. It's you're going to say more about what does the research say, and if the research is affirmative or not affirmative, what will that look like? For example, take the bonobo example I gave. You might say, to what extent can radioisotope dating be used to differentiate the sources of bones, or something like that. Although I would say that we're probably a little bit outside chemistry, because you're probably going to have to look at history and biology a little bit too much in the example I've given here. But the point being is, you would say, if I would expect the research to show that there would be statistical significant differences between different populations. If we're looking at that octane example, we might say that secondary research would have to show me that the additives didn't have a meaningful effect on the energy density of a fuel. We might also say that does the research indicate one way or another, where if an octane rating is based mainly on the hydrocarbons that are involved. Most fuels that are used in cars are going to be a blend of different branch chain hydrocarbons, so that might also be something that you would have a look at. And then the second part would be, the second thing I'm going to do is I'm going to have a primary investigation, which will have a method separately, but you would outline that I'm going to, perhaps take those fuels from a local fuel pump, and then I'm going to, rank them by octane ratings. I know you can get the plus, special, and super here, which is, I want to say 95, 97, 99, or something around there. I know in Oman, but I haven't seen a fuel pump here. They also do octane rating 90. And then you're going to use a calorimeter. Remember, we related it to the specification to identify the energy density in those fuels per gram. Then you could begin your analysis, and this is where you actually evaluate that secondary information. You start potentially compiling data and analyzing that data. You might graph different sources against each other. You might, or just compile conclusions from different papers and how they are relevant to your research question. And then on top of that, you would actually conduct an experiment. It's not a requirement that you conduct an experiment for a chemistry EE. However, most chemistry EEs that I've seen that have B or an A grade do include an experiment. This has kind of changed a little bit since COVID. A lot less people were able to do experiments. Little drink here. I love a bit of Vimto. If you're going to conduct an experiment, it is important for you to talk to the lab technician to make sure that you have the materials you need. If we don't have the glassware, we may need to order it if it's of a reasonable price, or you may need to order something and you may need to bring different components for it as well. It takes a long time for us to get chemicals in this region, glassware, and you really need to be ahead of the curve when you're talking about that, because you don't want to be waiting until the beginning of grade 12 to be conducting your experiment. The ideal situation is you do your mock exams at the end of the year, and then you conduct your IA experiment IA, you conduct your experiment so that then you can use that to help write it over the summer. So make sure that we have those, see what we have, and maybe you had an ideal in your mind, but maybe we already have it. See what we can get. So you may need to get a list of the lab technicians of things that you might want, and whether that's even possible, as many chemicals are heavily regulated here, especially if you're looking at things that have other chemical uses that have been restricted in the UAE. And then, of course, what you might need to source, as I've already mentioned. The conclusion then will fundamentally be based around answering the question, right? Of course, this is a good time to do things that you would usually do in your IA, like error processing, to work out, the significance of your answer. Look, if there's already values online, if you're investigating a trend or a value that may have already been calculated elsewhere, you may be able to compare your values to those and work out your percentage error. But you do need to kind of look into things like, here's where my systematic error was, processing your random error. Obviously, you can find videos on my channel for doing all of those things. So shameless little plug there. So the primary investigation may look quite a lot like an IA, at least in the method and processing of it, but then it will only form part of the overall conclusion to be able to give you that critical thinking mark that you really need to be able to succeed in the IA. So here you would have the scope to discuss things further, and that can be quite cool, especially if you're exploring something subjective. So take red hot chili peppers. So chili peppers contain, so capsicum is the genus, and they contain a compound called capsaicin. So capsaicin is directly related to the perception of heat when we eat a chili pepper. And there is another scale, a more subjective scale called the Scoville scale. So the Scoville scale is a scale on which we rate chili peppers and hot sauces, but it has some subjectivity to it. So maybe you could look into the relationship between those two things, in which case you would have to do some extractions of capsaicin from different chili peppers with different Scoville ratings. For example, that's just an example though. But you might also look at, emulsifier content in, foundation. You'll excuse my ignorance. Foundation content that you might have in makeup. So there may be certain chemical components of that that are more useful than others, so you may be interested in that, or you might be interested in looking at how the content of certain compounds such as zinc oxide in, what are they called, suntan lotions, how those how the concentration affects the UV resistance of the cream or topical solution. And you may be able to look at that by perhaps putting those creams on top of something that is very what's the word I'm looking for? It can be broken down by UV, and maybe you can use spectrophotometry to the spectrometer to be able to identify the concentration, right? So you do the compound by itself, you look at the intensity peak that you expect when it's just not been completely damaged by UV. Then you expose it to some UV radiation maximally with no protection, and then you do it with different brands or things that have different concentrations of zinc oxide. or any compound in all of these solutions. There's just myriad different ways you can explore this. To kind of summarize then, we have a topic that we develop a title and our question from. And in that intro from that, we develop a kind of method or approach where we have certain criteria that we're going to evaluate that question by. That might be through looking at primary data. You'll have to be aware that, if you're interested in degrading microplastics using certain compounds, that it may be more difficult for you to explore some of those things. So your primary investigation may be more of a simulacrum of the relationship rather than a direct relationship. A good example of this, I had a student a few years ago that was doing how acid affected teeth. He couldn't get teeth, which I was kind of okay with because it's kind of weird to get teeth. So instead, he looked at the different chemical composition of teeth, and I think he found out calcium carbonate was present in teeth. And so he looked at how different acid content affected calcium carbonate over time. Now, obviously, the composition of teeth, with mainly being like different polymers, this isn't an exact representation, but he could build it as an analogy to say that this is likely to have some kind of similarities. And then he approached secondary data, looking at those more specific values, which were harder for him to investigate. Those all get drawn through into kind of an analysis that you can kind of think they get drawn through into analysis, where they can start conclusion and discussion, where you say, well, I have this amount of error in my experiment, but this is in line with the secondary data, etc. Those kind of statements. And that's where we build our overall critical thinking. And these, this discussion and conclusion that we're drawing relates directly back to the question, so that we're actually making some kind of meaningful statement around the question. So in all, just don't be boring, and do double check, research, and make sure that the things that you want to do are actually realistic and possible within the framework of the school content. Almost forgot. Practice makes slightly better.